Local functions where one grid cell changes from the input layer or layers to the output layer can either be mathematical or logical in the type of operations that are acting on them. This is once again the mathematical operation where we're doing unary operation on the left, showing each grid cell multiplied by 2, and a binary operation on the right, where one grid cell is added to another grid cell, two mathematical operations. These mathematical operations here could be anything from exponentials to sine or cosine, to rounding numbers or square roots or powers, all of those things that we would do with mathematical operations. Another category of local functions is logical operations. And we'll start with logical operations that do scalar comparisons, so comparisons of individual numbers. And these are and, or, not, and, XOR, or the exclusive OR. So in this example here, we're looking at the and, or, and, not function. And so on the top column there, we can see and, the middle column, or I'm sorry, the top row is and, the middle row is or, and the bottom row is not. We can also kind of think of these as Venn diagrams, although be careful not to think of these as maps. But the and function means that both things have to be true in order for the output to be true, or the output to be true and get a value of 1. But with the or function, one or the other only has to be true in order for the output value to be 1. So just kind of quickly scanning the outputs for and or, we can see there's a lot more 1s in the or as we would expect. But let's take a look at a couple of specific cells here. What we can see is that we have a true. If we have a true and false for and, we get a 0. But if we have a true and true, we would get a 1. So, and of course null, a null value is just going to make any output grid cell null, regardless of which of the two input grids it's coming from. With the or, if we have a true and false, we get 1. And also if we have a true and true, we get 1, or a false and true. So in all of those cases, we would get a 1. The only time we will not get a 1 is if it's false and false. And in the not, we're just sort of flipping things. If we have a true, it turns out to be a false or a 0. And if we have a false, it turns out to be a true or a 1 in the output grid. And we can see the input can be any number, right, as long as it's not non-zero. For example, that would be a true value, so that -1 is a non-zero. It would also come out as 0. So this is a scalar comparison because we're comparing numbers. The XOR is the exclusive OR, and we can think of that like the Venn diagram on the right here. This is one where one can be true or the other can be true, and we'll get a 1. But if both are true, we get a 0. So once again, looking at some specific examples from this grid, we would see something like this, where if we have a true and a false, we would get a true. If we have a false and a true from the two input rasters, we would get a true. But if we have a true and a true or a false and a false, we would get a 0 value in the output grid.